Okay, this is lecture 2 in our series of mathematical lectures on JEE. Today's topic is plotting of one-dimensional functions. We shall concentrate mainly on algebraic functions. We shall plot two sets of curves. One set is we shall plot x to the power 0, that's 1, x to the power 1, that's x itself, and x square, x cube, x to the power 4 on the same graph. And the second we shall plot fx equals to, first we shall plot mod x, okay, then we shall plot x mod x minus 1, then we shall add these two, or what we shall do is we shall plot these three separately and we shall add them. Okay, so resultant function will be mod x plus mod of x minus 1 plus mod of x plus 1. Acha, in this light of these things, we shall discuss few important points. Acha, in this series, we have not dealt with differentiations as well. Yet, we will handle slope physically. We shall discuss what's a slope without going into calculus. But you can definitely see my lectures on derivatives, so there you will feel the geometric significance of slope. Anyway, in that context, or in this context of graphs, we shall discuss maxima. So that means where you have a maxima of the graph, both locally and globally anyway. Then minima, where it is minimum, where the point of inflections are. What is the point of inflection? That we shall discuss. What is an odd and even function? This is a very important tool to plot graphs. Means physical significance of odd and even functions. Then continuity and existence of derivatives. This part is definitely within the calculus, so we will touch upon a little bit on this, but will not go to the details of these things. We will do this after you see derivatives, but anyway we may. Let's see how this lecture progresses. After this algebraic, we shall plot this functions fx is equals to sin x, and here we will see few inflection points. What those inflection points will have a first derivative, again the language of calculus is coming, or the slope which is a non-zero. I will come to this. Generally is equal to n pi. So I shall try to remember the whole set, and let me start with this thing. So let me write things out. Then it's better you will remember this thing. So maxima, minima, odd even, continuity, okay, continuity, derivatives. Fine. So let me erase this part. Erase this part, and then these functions. So all these functions will first, this is the second function, plus mod of x minus 1 plus mod of x plus 1, and fx is equals to sin x. Okay, here you will get multiple inflection points, so that I don't digress while going through the lecture. Let me have a small writing on the right hand side. So let's start this plotting. Acha, first let me plot the graph. Means 1, suppose this is the x-axis and this is the y-axis, or y which is also is equals to function of x. Now let's plot x to the power 0. Which is x to the power 0? Can you tell me? X to the power 0 is 1. So let me coordinatize it first. Suppose this is 1. This is 1. Sorry, this is 2. This is minus 1. This is minus 2. This is 0. This again is minus 1. Minus 2. This is 1. This is 2. Now let me find the coordinate. Okay. This is fx is equals to 1, means this fx is equals to 1 for all values of x, right? So it is a constant function. So this is the function. Okay. This function is fx is equals to x to the power 0, that is equals to 1. Fine. Next, fx is equals to x to the power 1, that's x. So that should be a linear thing. You know that y is equals to mx plus c, right? So how can I write this? Y is fx, so y equals to 1 into x plus 0. So intercept is 0 and the slope is 1. So intercept is 0, the slope is 1. So this is a straight line. Now the important thing is this curve, when the value of x is 1, when the value of x is 1, so y equals to 1 for x equals to 1. So that is the point where it cuts this curve, right? So this is the curve. Okay, so this is fx is equals to 1. Oh, sorry, x to the power 1. So that's x. Clear? And this is the cutting point 1, 1. This point is very important in our set of graphs. You can easily see that in these sets of graphs, if I plug in x equals to 1, fx is equals to 1. If I plug in x equals to 1 here, and 1 square is 1. So this curve also passes through this point. 1 cube is also 1. This curve also passes through this point, and this curve also passes through this point. So this point is very, very important. Okay. So this is a linear curve. Now let's test this one. fx is equals to x square. Now see, for x square, now let me use this part, or an odd function and even function. What is an odd function? What is an even function? Okay, let's analyze that part first. Then we'll plot. Mathematical definition. Mathematical definition for even function. Mathematical definitions for even function. If you plug or if you replace x with minus x in the function, you will get the function back. So this is the mathematical definition of even function. And for odd function, f of minus x, this minus comes out, minus fx. So f of x is minus fx. Example, check these. Say here, this number 1, there is nothing here, no x is here, right? Or you can think that here you have an x to the power 0. So minus of x to the power 0 is 1 and x to the power 0 is also 1. So if you replace x with minus x, it doesn't matter, fx is always 1. So this one is even. Okay. Same for this x square. If you replace x with minus x whole square is even, but not with this. Because this one, see, if you replace x by minus x, suppose here you have fx is equals to x. Now if you replace x with minus x, so minus x, so f of minus x is what? X is replaced by minus x, that is minus comes out, x is fx, right? X is fx. If you take this example, so x is fx, so fx is equals to minus fx, so this one is odd. Take this one. Oh, this is a definite, I should write it here, sorry. Example, f of x is equals to x. So if you replace this with minus x, you get minus x. Fine? See? So this you can write minus of function of x. So fx, f of minus x minus fx. So that's all. This one. This is an odd function. What about this one? X square. Test it. Very simple. Minus x whole square is x square. You get back the function. So f of minus x equals to fx. So that's even. This one is even. This one minus x whole cube. That's minus of x cube. So that's odd. And this one is even. So even, odd, odd. So this is the mathematical definition. I am repeating it again. If f of minus x is fx, the function is even. If f of minus x is minus fx, if this minus comes out, then the function is odd. So these are examples of both even and odd functions. This is even, the one is even. This is odd, this is even, this is odd, and this is even. What's the geometrical significance? Let's see how geometrically this goes. Okay. Geometrical significance. Geometrical significance of even and odd functions. You take this as a mirror, this y-axis as a mirror. If this y-axis acts as a mirror, that means right side of any function is reflected by this mirror on this left hand side, right? The right side of the function is reflected exactly by a plane mirror, which is this y-axis or the fx axis, then the function is even. On the contrary, if you take a pinhole camera light structure and suppose this is the hole, and whatever is here or here, just it's an image of a pinhole camera on the other side. That means whatever you have in the first quadrant, it will be reflected in the third quadrant. If you have something in this quadrant, it will be reflected here. So if it is a pinhole camera light structure, then if it is a pinhole camera light structure, then you have a odd function. Just a little digress. I tell you one thing. Suppose if a function is odd, if you multiply with another odd function, right? You multiply, the resultant is an even function. You can test it. Suppose this one is fx, gx, and this one is hx. Odd, how you will test? Just replace x by minus x. So g of minus x into h of minus x. Now in this case, this minus comes out, minus g of x into minus h of x. So this minus goes. So that is, what shall I say? Gx into hx. In this line, you have replaced x by minus x. So you can check these things. Odd into odd is even. Odd into even is odd. You can, if you divide it, it will be the same thing. Means odd divided by the odd is also even, and odd divided by, so multiplication, or division, anyway. So multiplication or division. Acha. Then odd plus odd is equals to odd. Odd plus even, I don't know. Actually, any function, any one-dimensional function can be replaced as a sum of odd function and even functions. And this property is very important. So odd plus even is basically odd plus even. Fine. And plus is also replaced with, can be replaced by subtraction. So that means either it's a multiplication or a division, or a plus, or can be replaced by subtraction. So these are properties you can check. You can take any combination, odd, even is, if you multiply even with even, or you divide even by even, that is even. So you can see all these combinations. So that is one part you must test. So let me go to the graphs. Let me go to the next graph, x squared. X squared is what? X squared is even. Fine. X squared is even. That means, suppose, that means whatever you have on this side, it will be reflected exactly here by this y-axis. Now, see, between 0 to 1, the very important thing is for all x, for fx is equals to x squared, and for all x belongs to the open interval 0 and 1, means here in this interval, in this small interval between 0 and 1, not including 0 or 1, this is 0, x squared is always less than x. Take an example, half. Half square is 1/4. If x is half, half square is 1/4. So 1/4 is less than half. So here the function is less than this curve, right? But for all x greater than 1, x square is greater than x. But beyond this limit, it is greater than x. And definitely you can see that at x equals to 1, the curve is same. So all the points, all these cells, all these functions will cut at x equals to 1. So let's plot this. And equals to 1 for fx is equals to 1. Anyway. So let me plot it. I'm just plotting the nature. So and if I plot one side, this is reflected on the other side by this y-axis. So that's a U-shaped curve. It's approximately like this. This is a parabola. Okay. Okay. Now take the next one. fx is equals to x cube. Very similar, but is x cube odd or even? X cube is odd. So let me point these curves. So this is x square. Okay. This is x and this is 1. Okay, it's already written, fx is equals to 1. Now what about x cube? So fx is equals to x cube. Achha, before going into this function, let me tell you one thing. See, this curve fx equals to x square has a minima at x equals to 0. Okay, I'll discuss maxima minima in the light of calculus a bit later, but now you try to understand it physically. Okay, this lecture is before you go into calculus. This lecture is before you go into calculus. Try to visualize curves. This is very important in physics. The independent parameter may be time and the dependent parameter may be displacement. So you may have a displacement time curve like this, and you people may be asked to find the velocities. You have to differentiate. There may be discontinuity in the velocity. You will see once I plot y equals to mod x curve, if x is replaced by t and y is the displacement, so dy dt, you have a discontinuity at t equal to 0, there will be a reflection and something will go and hit and immediately velocity changes. So things of this sort will come. But that's the reason I'm going into this curves and stressing on this curve. This is very, very important. You must understand the mathematical tools. Okay, fx equals to x cube. If it is x cube, now see, same for all x belongs to the open interval 0 and 1, x cube is less than x square. Naturally, because again you take the example half cube is 1 by 8, half square is 1/4, so 1 by 8 is less than 1/4. So here the curve cuts and comes down. So I'm plotting the right hand side only. The rest of the curves on this side will be handled by either it's odd or even. If it is odd, it will be reflected as a pinhole camera like structure. In this case it will do so. In the previous case it was like a mirror like structure, y reflected. Oh, it's a reflection by the y axis. Anyway, let's plot this. This is x square. So let me write here. This one is x square. So x cube will be answer, and for all x belongs to, or for all x greater than 1, x cube is greater than x square. So this side it is higher than x square. So let's plot it like this. Plot it like this. This will cut this point and it will come here. Okay. Okay. Now what about this curve on this side? This is exactly a reflection here. I would like a pinhole camera. See, this function fx is equals to x. This is also basically an odd function, right? It is, this line is reflected by the pinhole camera and it is here. In this side it is reflected here, right? This will do so the same way. Now let me now mark this point fx is equals to -1, because that is also important in this case, because see, for x equals to -1, fx is also -1 when fx is equals to x, and x cube is also -1 because 1 cube is -1 when fx equals to x cube. So this line, this red line will cut this line. in this third quadrant. Right? So schematic light diagram. This is the -1 point, and it will cut here. This is x cube. See, this is the odd function. It cuts here, and here you try to. Let me go into this point of inflection a little bit also. Now, what's a point of inflection? See, before going into the point of inflection, let me discuss slope of a curve. Suppose you have a straight line curve. Say this line. You are coming from you're just joining 11 actually. This is the course a little bit advanced. So slope of this curve is this line by this line. In case of a straight line, the slope is always constant. So if you say that slope of a curve, it means nothing. Slope of a curve at a point. If you do not define the point, then it's no points telling what is the curve, means what is the slope. So for example, suppose it's here. This is the point. You need the slope of this curve at this point. What shall you do? You draw a straight line. You draw a straight line, and this straight line is a tangent, right? This tangent. Then what you do is you draw a triangle. This by this. Naturally, the slope will be negative. Tan of this obtuse angle is negative. So you get a negative slope. But see, these tangents, as you go along this curve, if you go along the increasing value of x, slowly the slope goes more negative, because then it becomes 0. Then it tries to increase. So slowly it is a monotonic increment of the slope as you increase x, this thing. So the slope always increases, right? But see the red curve. If you go this way, the slope decreases. Slope decreases means you draw a tangent. You take any point, you draw a tangent, and then you make a triangle. The slope means this angle. This here the slope means, if this is theta, so slope is m equals to tan of theta. What you do is you take a point, and you draw a tangent to this point. Tangent of a curve at this point, right? In this case, this is theta, right? So the thing is, this is theta. Now this slope, as you go, the slope decreases. It becomes 0. Then it starts increasing. So the point. Okay. Now, so for this line, this is the slope. This theta is the slope. Okay, fine. Now, as we go like this, the slope decreases. The slope decreases. As we go like this, the slope decreases, and here it stops decreasing, and it then here is increases. Now, point is, what is the point of inflection? This point is the point of inflection. Point of inflection. As far as this red curve is concerned, for y equals to x cube. Why is the point of inflection? Because here the slope changes its motion. Remember, it is not necessary that at the point of inflection the slope will be 0. No. I'll give you an example. very simple example. You will do this. Suppose this is the curve y equals to sine x. And those who know calculus, they definitely know that this is sine x curve. Now if I take a derivative of this curve, this will be like this. This is pi over 2. This is pi. So the ddx of sine x is cos x. The slope is cos x, right? So now if I plot this cos x curve, it's like this. Now see, as far as this part is concerned, the slope of this green curve, the slope of this green curve is basically the tangent at every point. The slope is this, like this. It's the tangent of every point. At x equals to pi, the slope is this, right? The slope is this. Here at x equals to pi, the slope stops decreasing, and here it starts increasing. So what's the value of the slope at x equals to pi? Means it is this thing, 135 degrees. So tan 135 degrees is -1. That is actually cos pi. Cos pi is also -1, right? So the red curve is the cos x curve, which is the value of the slope. So this is the point of inflection. This point is the point of inflection. Remember, for y equals to sine x. So as far as point of inflection is concerned, it is not necessary that at the point of inflection the slope is 0. No. At the point of inflection, the slope changes its motion. It changes its motion. If it in this case, it was decreasing. Here it stops decreasing and increases. Now here, at this point is also a point of inflection. This is 2 pi, cos 2 pi is 1. So basically here the value of the slope is 1. What happens is, here the slope stops increasing and start decreasing. Here at this point the value of the slope is 1. I tell you, just in addition to this, I tell you one thing, that the point of inflection, the second derivative of this curve, this green curve, should be 0. Second derivative of this curve means first derivative of the slope, because where the slope changes its motion, if it was decreasing, it starts increasing, and if it is increasing, it starts decreasing. So what happens is, the slope changes its motion where a function changes its motion, where the derivative of the slope is 0, right? So derivative of the red curve is 0 at the point of inflection. First derivative of the red curve is equivalent to the second derivative of this green curve. We'll come to this in detail when we'll analyze point of inflection, but remember, as far as point of inflection is concerned, that is the point where the slope of the function changes its motion, right? From decreasing to increasing, or from increasing to decreasing. Okay, this is just a little bit of a point I need to add. Anyway, now let's plot this curve y equals to x to the power 4. It's very similar. It is also an even function, so this will be reflected here. And again, as far as this x to the power 4 is concerned, this will cut at this point. It will be down here, and again it will be more here, right? So let's plot this x to the power 4. So I don't want to stress too much on this. So this is x to the power 4. Okay, this is a blunt. This is very similar. This is a little similar to x square, and but it is this u is blunt. It's not as sharp as y equals to x square. It is a little blunt. So this is x4, So remember, so this is a set of curves, 1x, x square, x cube, x to the power 4. So if I give you a general polynomial, suppose fx equals to something, some constant a0 plus a1x plus a2x square plus a3x to the power 4 plus dot 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 dot. If it is given like this, it is basically the sum of all these curves. Okay, the sum of all these curves. Remember, odd function and even function is very important. I have discussed in this lecture. Discontinuity I have not discussed, derivative definitely I have not discussed, but maxima minima, well, these x4 x square have minimas at this point. This red curve y equals to x cube have neither minima nor maxima at this point. This point is also, in this case it's a point of inflection, and this point is the stationary point. It's called the stationary point. Maximum minimas are also stationary points where the function is derivative of the function, the first derivative of the function is 0. So remember this is important. I think we are going too long in this lecture, so what I do is I stop this lecture and go to the second part of the lecture where I plot this function fx equals to x plus x minus x plus this thing, this mod x plus mod x minus 1 plus mod x plus 1. One thing I want to tell you, mathematically this function is even. Fx or this function is even. You can see by symmetry, it is very symmetric about x equals to 0. If you replace x by minus x, this function is you get the same function back. So this function is even. If this function is even, it is whatever we have on the left side, exact mirror image will come on the, what we have on the right side, exact mirror image will come on the left side. In my class I have given all the functions. You must plot all the functions. I hope you will do it. Let's go to the second lecture where I do this plotting of modulus functions. Plotting of function is very important. I shall try to plot many functions, as many functions as possible for you. There are many softwares which plot functions, but what the thing is, it is very important that you plot it. You understand the nature of the function. In the examination hall you will not be given any softwares, so you plot the nature of the functions, feel where the function is continuous, smooth, limit exists, limit doesn't exist. Mathematics is the language